Hey guys, today's the last day of Module 21. This is a really super important lesson, so make sure you watch the whole thing through. The beginning is easy and the second half of the lesson is a little bit confusing, so make sure you don't just say, okay, this is easy enough, I don't need to finish watching the video. Make sure you go through the whole thing. What we're going to talk about today is angle-angle similarity, which is basically something you're going to need in geometry very much. You are going to be doing proofs eventually, which means that you're going to have to take two shapes, two figures, and prove mathematically that they are either similar or congruent, or that they are a certain shape, and it gets a little bit crazy. So this is the basis for that, okay? And it's super important, and there's very important geometry problems that you're going to learn basically how to solve right now in 7th grade. And if you know it now, you're just going to be able to build on the strength by the time you get to 9th grade or 10th grade, depending on what you choose to do. So please take this lesson seriously. So as we go further and further into math, like I just was saying, you'll start to begin proving that the things you've learned are really true using math and algebra. So a lot of times I get the questions, where did this come from? Who made this up? The thing is, nobody made anything up. They just discovered it. And you can prove all of these things that we learn in math by using algebra, using theorems, and using things like we call postulates. We call them properties. There's all sorts of things. And they're basically just statements that we know are mathematically true. And you can use all of that to prove something. So one of the types of proofs that you're going to learn about in geometry is proving that triangles are similar. It's a very common one. And today what you're going to do is you're going to learn one of the ways that you can actually prove that they're similar. And that is, as I said before, the word postulate, the angle-angle similarity postulate. And we're going to use AA for short, okay? So what this means is that if we know two angles of one triangle are congruent to two triangles of another, then the triangles are similar. So I tried to make it as easy as possible for you guys. In other words, if we can show that two angles in each triangle are congruent to each other, then we can prove that they're similar. What did we learn about similar triangles? We learned that their angles are the same. So what we just learned yesterday about the triangle theorems, was necessary for us to go into this, because we need to know that the sum of the angles inside of a triangle is equal to 180. This is all going to be used in this lesson. So here's why we only need to know that two of them are congruent. Let's say I know that this angle is congruent to this angle, okay? And I also know this angle is congruent to this angle. Because all the angles in a triangle have to add up to 180, that means that the third angle has to be the same too. Because there's no way. If these two, let's say these two is maybe 120, and this is also 120, the only option left would be 60. So it's enough to just prove that two of them are congruent, because if two are, then we know the third one is as well. Okay? So what we're going to do first is we're going to practice explaining how we know that they're similar. So what you need to be able to do is just simply prove that two of them are congruent. So what you can see here is we're given angle B and angle E, we can see are congruent, right? So we can see measure of angle B is congruent, and I can't remember if I taught you this already, but this is the congruent symbol. You make a little squiggly and two lines underneath it. It's congruent to the measure of angle E, okay? And what we see here is a measure of angle A is 45 and F is 35. So that's not helping me, because first of all, they're not corresponding angles. So what I need to see is, can I figure out what the missing angles are and see if perhaps they are equal? Because remember, it's corresponding angles. So what you want to do is you want to find the missing angles first. So over here, I know that the measure of angle A plus the measure of angle B plus the measure of angle C is equal to 180. So I'm going to do 100 plus 45 plus the measure of angle C is going to give me 180. So this is 145 plus the measure of angle C is 180. Subtracting 145 from both sides, I can see that the measure of angle C is equal to 35 degrees. Would you look at that? How nice. Now I can see that the measure of angle C is congruent to the measure of angle F. Okay? Now you could go over here and find that this is equal to 45, but what I told you before is that you only need 2, because if we know 2 are equal, then the last one's got to be equal to. So what we want to practice is explaining why these are similar. I can now conclude that they're similar. So what we're going to say is the two triangles are similar because two angles in the first triangle, we'll just say first, are congruent to two angles in the second. Okay? So we know that two angles are congruent. That's enough to conclude that they're similar. Now I included this here. I threw it in because in the practice that we're going to do tomorrow, there's a lot of examples like this, and I noticed that the textbook didn't include any like this, and this is a very common one that you'll see in geometry. This one is flipped over like this, but it could also look just straight up and down like this. What you will commonly see in geometry is an angle that is inside of another angle. So like this is a small triangle. If I pulled it out, I said angle, but I meant triangle, sorry. If you pulled the little one outside and you pulled the big one without the little one, it would look like this. Okay, so basically this is just put inside the other triangle. Same thing here. Whenever you have something like this, these triangles will be similar as long as this line is parallel to this one. And one of the things that we know once that happens is that this angle and this angle are congruent, as are this one and this one. So when you have a triangle like this, as you can see, that is split up into two triangles inside, what you have is, it has to be parallel, okay? And you'll get into that in geometry. But what you know is that these two angles are equal, okay? So I wanted to just throw that out there because there are a few examples like this in your practice. For tomorrow, I don't think it's any in today. Okay, so for these two, we're going to explain whether or not they are similar. So let's take a peek. Actually, let me make sure. Did I give you guys more? Oh yeah, I wanted you guys to do this one. Okay, so I want you to do exactly the same way that I did this. Test it out. See if these two are similar or not. And then pause it, try it, and then unpause to check. Okie dokie. So hopefully you saw that these two triangles are not similar. Over here, what I did was I found the missing angle. You can kind of eyeball it and tell that they might not be similar. Sometimes it's hard to tell because you have to remember that one triangle might be smaller when something is similar. It doesn't have to be the same size. So if you turn it around, maybe it will look like that same triangle. It's hard to tell, so the only way to be sure is to actually calculate it. So I find my missing angle and I find that it's 52 degrees. And I actually don't have to find the other angle here. I just did it to show you guys. But I know that if this one's 52, there was no way that I could have ended up with a 49 here, because I have a 58 and a 52, and there was just no way it would happen. So knowing that, here it would be impossible for them to be similar, because all of the angles have to be congruent when two triangles are similar. all we need to prove it is 2, but they all have to be congruent. So you didn't even have to go through and find the 61 here, but if you wanted to, just to convince yourself, you can. Just knowing that this is 52 is enough. I only have one angle here that is congruent, and so the 2 triangles are not similar. Okay? All right, so we're going to take it up a notch, and we're going to now talk about the sides of similar triangles, and what we learned about with dilations is going to apply here. So we are going to be able to actually find missing measures in similar triangles, not just with angles, but also with sides. So this is the most important thing here. Something that we learned about similar figures when we did dilations was that the corresponding sides were in proportion. Knowing these 2 facts can help us to solve real-world problems that involve similar triangles. The first fact being corresponding angles are congruent, and then corresponding sides are in proportion. If you have your notes printed out here, star this 1,000,000 times, bubble it, highlight it, anything. This is the most important takeaway right here from this part of the lesson. 2 most important things that you need to know to solve any type of a problem involving similar triangles. And I'm not even kidding you. The most important thing, the corresponding angles are congruent. And remember, corresponding means that they match up. And the corresponding sides are in proportion. This is going to allow us to solve literally any type of a problem involving similar triangles. So let's see the first type. So we have the most common type of a problem is going to be an angle that something is happening at a farther away point, and then what we're going to be doing is we're going to be looking at one height and then another height from further away, seeing that the angle is the same. So as I told you before, this is like a little tiny triangle inside another larger triangle. So I'm going to show you first. Let's talk about what this problem is about, of course. While playing tennis, Matt is 12 meters from the net. Here's the net. He's 12 meters away from that, okay? And the net is 0.9 meters high, so this height is 0.9 meters. He needs to hit the ball so that it just clears the net and lands 6 meters beyond the base of the net. So he wants the ball to land here. This distance is 6 meters away from the net. At what height should Matt hit the tennis ball? So we're trying to figure out how high up should he be when he hits it so that this angle is exactly right and it lands 6 meters away. Okay? Might seem a little bit kooky, but this is the type of a problem that we're going to be dealing with. So before I do anything else, what I'm going to do is I'm going to break this up for you a tiny bit. What's said here is that both triangles contain angle A, which is here, and a right angle. And so that's enough for us to conclude that they're similar. So we can apply the 2 things that we know. So I'm going to just quickly sketch the little triangles separately for you and the big triangles separately. So this is A, B, and C. And what we're going to do is every time we solve a problem like this, we're going to sketch it out like this. So 6 meters, this is 6 meters, and this is 0.9 meters, okay? Now, I know that angle A is the same in both of these triangles, right? Now I'm going to take the big triangle, okay? It's not going to be really accurate because I don't have too much space here. Okay, the sketch is fine. This is still A, but now this is D and E. And this is a right angle, okay? And now when I label this last piece here, what we have to be careful about is this side of the triangle is this whole thing. So it is equal to 6 plus 12, not just 12. The 12 is only up to this point. So to get that whole length, 6 and 12, so that's 18 meters. And we're trying to figure out what height he should jump at, so that's going to be X. Okay, now this setup is crucial for you to be able to solve this problem. If you don't take the time to do this step, you are going to struggle, okay? So please just take the time to write out the two triangles like this. It'll really help because what we now have to do is apply what we know that the corresponding sides are in proportion. So what that means is I know that the matching sides, the corresponding sides, have the same proportion, okay? So you can do this one of two ways. You can do it from the small triangle to the large triangle, or from the large triangle to the small triangle. It's not going to change your answer, but we're writing a ratio, okay? Because remember, they're in a proportion. So what I want to do is I want to say that side AB is in a ratio with AD. So it's going to be AB to AD, and that's going to be equal to, the ratio between these two is going to be exactly the same as the ratio between CB and ED. So that's going to be BC and DE. You take the step to set it up, and now I'm going to be able to figure out what this missing side is because I know how to solve a proportion. So I'm going to just fill in the lengths that I know. AB is 6. So 6 over 18, which is AD, is equal to BC, which is 0.9 over DE. And now I'm going to be able to find this. I'm sorry, I was supposed to write X. Ay. Sorry, guys. X. Oh, my Lord. Okay. And now all we have to do is solve this proportion by cross multiplying. Remember? 6 times X is 6X. And 18 times 0.9, 16.2. Divide both sides by 6. And when you plug that in your calculator, you'll find that it's equal to 2.7. And now you know that Matt should be at a height of 2.7 meters when he hits the ball. Okay? So this is the type of problem you're going to have to do. It's very, 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 very important for geometry. I know it's very new and a little bit confusing, so we're going to do another one, but let me talk you through it one more time. You have two similar triangles. You have to make sure you know that they're similar first. They're sharing this angle A, so that's one angle, and then they both have 90-degree angles, so they have two congruent angles, so we know that they're similar. And because they're similar, I know that the corresponding sides, or the matching sides, are in proportion, which means that when I put them in a ratio, that ratio is equal every time. So if I do 6 over 18, that's going to be equal to 0.9 over X. Now you can also switch the order. You can say 18 over 6 is equal to X over 0.9. You will get the same answer, I promise. Okay, let's try the your turn together. And I know that this is kind of a tricky topic. So, number 5 here, Rosie's building a wheelchair ramp that is 24 feet long and 2 feet high. So here's the ramp. The whole thing is 24 feet long and 2 feet high. She needs to install a vertical support piece right here, 8 feet away from the end of the ramp. What's the length of the support piece? So basically what we're trying to find is how high up from the ground is the ramp by 8 feet. Before anything, we have to just make sure we do know. They're not telling us that this is a right angle, but we have to assume it. We know that we're sharing this angle, and they're both right angles, so that means that they're similar. So there is not enough room here. So I'm going to actually go to the back real quick to sketch this for you guys. My little triangle is going to look like this. Okay? And I know that this is 8 feet. Okay? And I'm looking for this. I think they gave us H, right? We're looking for H, the height. And then I have the larger triangle. Okay? This is not the same as the one in the picture, so just bear with me here. And what am I given? I know that this is 24 feet. And my height here is 2 feet. Okay? So I'm going to use what I know about similar triangles. Okay, I know that the corresponding sides are in proportion. So I know that this side matches with this side. So I can put those into a ratio. 8 over 24 is going to be equal to h over the matching side, which is 2. Something I didn't mention before, and I have to mention, is that however you set up your proportion, your ratio, you have to keep the same order. So what I mean by that is, if I do 8 over 24, I have to start with the small triangle here, h over 2. I can't do 8 over 24 and then 2 over h. I have to stay in the same order. If I'm going from small to large, I have to go from small to large in the next one as well. And now I cross multiply. 24h is equal to 16. And now I'm going to divide both sides by 24. And I'm going to get h is equal to, we can divide both of these by 8. So this will be 2/3. So this problem, when I included this, I was thinking about maybe not including it because it's a little bit tricky, because they gave us the units in feet. So this is 2/3 of a foot. So you could leave it like that, or you could convert it into inches, which is what I noticed when I looked in the textbook version of it. They converted it into inches. So you can do that. I would be fine with you leaving it like this, but I'll also say 2/3 of a foot. If you think about it, there's 2/3 of a foot. My cats are making so much noise. There's 12 inches in a foot, right? So 2/3 of that would be 8 inches. And I'm not going to require that you guys do something like that. 2/3 of a foot would be fine for me, okay? 2/3 of a foot. Okay, so that's how you would do that one. Let's turn back and take a look at 6. This is a super common type of question where you're looking at a height from here, and there's an angle down here, and distances. So let's read what we have. The lower cable, that's this one, meets the tree at a height of 6 feet. So that's here. They're having us label this one ourselves. This is a height of 6 feet here. Okay? And it extends out 16 feet from the base. So that means this is 16 feet. Okay, from here to here. If these two triangles are similar, how tall is the tree? So I'm going to just sketch this out. I have space down here. So my small triangle is over here. Okay. This is a height of 6 feet. And this is a length of 16 feet. And then the large triangle, I'm trying to find this height of the tree. Okay. So this is going to be my x. I'm trying to figure out how tall it is. And I know that this cable here is 56 feet. Okay. So again, I can assume that these are similar because we are sharing this angle here. And technically these two angles are the same. I'm not going to get into that in this lesson. I guess they're not having you prove it. So we're just going to assume for now. So we're going to set up our proportion. Again, the order does not matter. So you can do large to small or small to large. So I'm going to do small to large. I just typically always do it that way. So 6 feet matches up with x, right? Those are the corresponding sides. So I'm going to do 6 over x. Okay, and I follow the same order. So if I started with the small one, I start with the small one again. 16 matches up with 56. So that's going to be equal to 16 over 56. And now we're going to cross multiply. I'm going to have you guys just finish up this problem on your own because it's the last one in the lesson. Now that I set it up for you. And you can give that a shot and then unpause and make sure you got the right number. Okay guys, so hopefully you got 21 feet. you cross multiply and divide, and you find that x is 21. Okay, so I hope that this isn't too crazy. I know it's just something very different than what you're used to. The most important thing is being able to match up the sides. And I'm not sure that I did a good job of matching them up for you. If you want, I was going to say you could use different color highlighters or colored pencils or anything to show, this side matches with this side, right? And then another color, and you'd say, I only have black here, but this side matches up with this side. Sometimes the triangles they give you might be turned differently, and the problem is you have to turn them back so you can see it, stuff like that, okay? And just remember that the order matters. So if you start with the smaller triangle and put the other side underneath, you have to stay consistent. You can't switch it up. So just like I said before, if you're doing 6 over x, you can't just switch and go 56 over 16. You have to keep the order. So if I say 6 over x, then I have to say that's equal to 16 over 56. That's very important. Okay, guys? So that's that, and tomorrow you'll have a whole day of practicing this, so don't worry if it's a little bit tricky. You'll get some good practice, and I'll be posting answer keys for you. Okay, have some fun.